let's start, because I suppose we have only 1 hour and 5 papers. So I just put in the chat the different CV of the speakers. So I propose to just, you have the 5 paper titled in the slides, and I propose we already start very quickly with the presentation. Like that, we can have more time for discussion, because if everybody's okay. So is the moderator, is Maria who launched the video?
Hello everyone, I'm pleased to present this article co-written with Cédric Masclet and Jean-François Boujut, called The Co-Design Cognitive Process Impacts of a Spatial Augmented Reality Platform. This paper is part of my thesis work, whose objectives are to provide knowledge on the cognitive and gestural processes used in the interaction between designers and clients on the one hand, and on the other hand to identify the impacts of a spatial augmented reality platform used as a design edge tool throughout my thesis. It's this last point that will be addressed in this presentation. First, let me introduce the SAR technology. The spatial augmented reality is a technology that uses a projection mapping of a virtual image on a tangible artifact. The benefits of SAR are that stakeholders can apply changes to the product in real time. This allows them to share their internal representation almost instantaneously by displaying the modification onto the artifact. In order to know if the SAR technology has an impact on the cognitive and gestural processes, we have observed 2 design sessions led by a design agency. One used the conventional material, while the other one used the SAR technology. These sessions were registered by video and microphone, allowing us to proceed to a protocol analysis. On these observations, we applied our gestural and activity coding chain developed thanks to previous works analyzing the co-design process. According with the literature and design cognitive activities we directly observed in practice. The cognitive activity classification and the gestural classification also are as follows. These 2 classifications were validated thanks to an intercoder reliability test. And let's come back to our research question. Does the SAR technology have an impact on the co-design process? To answer this question, we analyzed 3 things. The rate of interactions between designers and clients, the rate of gestures used by them, and the rate of cognitive activities. The results obtained regarding the interaction rate show that clients interact more in the SAR condition, with 75% of participation against 57.5% in the traditional condition. This tends to support the idea of a better performance of SAR for clients' participation. For the gestures rate, we can see that each modality of gestures that is not artifact-centric is distributed in quite equivalent way between SAR and traditional condition. We can explain the differences that exist for tangible, digital, and mixed gestures because conditions are different. And therefore, the stakeholders don't manipulate or point the same nature of artifacts. That's why we will prefer in the future to make conclusion by associating these 3 kinds of gestures. Note that these 3 modalities grouped results in 41.9% and 41.2% of use in respectively traditional and SAR condition. To conclude, we can say that gestures are quite similar between the SAR and the traditional condition. And to finish, the last analysis we made was on the cognitive activities mobilized during the co-design sessions. We proceeded as for the gestures analysis, and the results show that all the different modality of cognitive activities are quite equally distributed in both conditions. The biggest differences we can notice are for the interpretation activity and the acceptance activity. In general, the results obtained here also support our hypothesis of equivalence between the SAR condition and the conventional tradition. This work gives us a first indication of the advantages of SAR regarding the reduction of barriers between clients and designers during a co-design session. This study also shows that the SAR technology doesn't drastically change the cognitive and gestural process of stakeholders, but this deserves further analysis with a larger number of observations. Thanks for listening.
The point about Maud won't be there with us, so you can send in the chat. You can say email address if you want to ask questions to her.
Hello, and thanks for watching this presentation. My name is Välk. I'm a designer and researcher developing methods and tools for innovation-driven collaborations at Imperial College London. Today, I would like to present our findings from a series of idea generation sessions between synthetic biologists and design engineers, which were conducted at the Dyson School of Design Engineering, where I'm currently a PhD candidate working with Dr. Céline Mougenot. The key insight from this study is that generative boundary objects are integral parts of framing in design and bioscience collaborations. This research is motivated by the need for a more sustainable and bio-based future, which calls for new forms of interdisciplinary collaboration. And we believe that designers have a key role to play in this future. Our initial literature review revealed that there is a growing interest in combining design with science to create innovative products. But interdisciplinary projects often fall short from making a significant societal impact. Part of the problem is that collaborative projects are very difficult to manage and take part in, because of boundaries between practices and challenging interactions between practitioners. We do think that such collaborations could be leveraged by introducing specific support tools and methods. We have identified that one way to build support tools for science and design collaborations is to view their interactions through the creativity lens. K-Store's framing concept proposes that defining and framing the problem is the key aspect of creativity. We also know that framing is influenced by information and knowledge sharing, which is particularly challenging in difficult interdisciplinary collaborations. To develop understanding on this knowledge sharing, we analyzed idea generation through boundary objects. Understanding about boundary objects that facilitate framing will enable implementation of strategies and interventions for teams that aim to produce creative and innovative ideas. Our question for this research was to identify different types of boundary objects and their relationship to framing. We found 5 types of boundary objects from literature. We gathered these into a taxonomy to gain an overview of boundary objects with different qualities. To deepen our insight, we observed 4 ideation sessions between synthetic biologists and design engineers, where they were provided with an open-ended brief to develop an innovative concept. The criteria used for innovation was twofold. Firstly, the ideas had to be novel, and secondly, they also needed to be useful. As a starting point, we set the domain for the ideation session. This was healthcare, with all its subcategories, ranging from medical applications to subjective well-being and so on. For our analysis, we conducted a verbal protocol analysis together with collection of all sketches, notes, prototypes, graphs that were produced during the session. Altogether, we observed and analyzed over 6 hours of audio and video, which covered the sessions from start to finish. The total time we found to be centered around various boundary objects was 1 hour and 21 minutes. We managed to identify 84 different verbal and non-verbal boundary objects from all sessions. The most commonly occurring boundary object was of explanatory nature, which is not surprising given the diverse expertise areas of the practitioners. We believe that the main outcome of explanatory boundary objects was to align the collaborators' views and build a shared understanding. We found that the majority of generative boundary objects had the direct capability to incite framing. We also found that 25 generative boundary objects in use illustrate the significance of co-creation as part of the knowledge-sharing process in bioscience and design collaborations. The findings from this study indicate that generative boundary objects in use are integral for framing to take place. This leads us to question, how might we design and support interdisciplinary collaborations by imposing tools which specifically aim at triggering the creation and emergence of generative boundary objects? We are also interested in exploring the sequence of different boundary objects and whether facilitating interactions that lead to a more structured collaboration process would be useful in terms of arriving at more creative ideas. Thank you very much for your attention, and I look forward to the discussion.
Hi, and welcome to this presentation for the Design 2020 conference. This is a presentation of the paper, The KARAKURI Card Deck, Co-Designing Industrial Internet of Things Conceptual Solutions, written by Álvaro Aranda, Ulrika Florin, Yvonne Eriksson, Yuji Yamamoto, and Kristian Sandström. In industrial settings, shop floor personnel often face simple problems, such as, for example, moving work orders around the factory or checking the status of machines, which may be located at a distance from each other, and which often lead to 600-meter walks in industrial environments just to check if a process has finished or not. These problems could be addressed with Internet of Things technology, using sensors such as accelerometers, distance sensors, temperature sensors, etc. However, shop floor personnel seeking solutions for these problems lack the necessary computational and making literacy. This study employs a design perspective in considering how, through a bottom-up approach, shop floor personnel can be supported in the conceiving of Internet of Things conceptual solutions, which address daily routine problems and allow them to capitalize on opportunities. As a way to explore this design perspective, we have created the KARAKURI Card Deck, and we have carried out a case study composed of 4 workshops in a variety of large manufacturing companies in Sweden. On the left, you can see a rough version of the card deck, which was used in a pilot study. On the right, you can see some sensors cards of the Fanatec of cards, refined from the observations made during the pilot. This refined deck was tested in 3 different manufacturing companies. And the cards of this deck represent a combination of modern Internet of Things technology that can be used by shop floor personnel to conceptually solve common problems presented in industrial settings. The research team questions that drove this study is the following. Are shop personnel able to ideate possible Internet of Things conceptual solutions with the help of the KARAKURI cards? This study involves a university department, one that is specialized in design and improvement of production systems, and another specialized in information design. Also 2 research institutes and 6 manufacturing companies, 4 large and 2 small companies, all located in Sweden. And this study is part of a 3-year research project that started in 2018, named KARAKURI IoT, and is inspired by the KARAKURI Kaizen movement in Japan. The goal of the project is to guide participants from ideation to prototyping of Internet of Things concepts, and this is presented in the 4 stages that you can see in the image. First, it is about supporting shop floor personnel to identify opportunities in the shop floor. Then, on the second stage, it's more like focusing on supporting them, the shop floor personnel, to create conceptual solutions. In the third stage, shop floor personnel prototype their conceptual solutions. And lastly, in the last stage is when they test the prototype in their environment. The focus of this paper is on stage 2 of this methodology, where the KARAKURI cards support shop floor personnel to come up with conceptual solutions based on their previous identified opportunities from stage 1. During the workshops, we followed a co-design approach. The duration of each workshop varied from 2 to 2.5 hours. Each workshop started with a simple description of the KARAKURI methodology, in which the KARAKURI cards were shown. Then participants worked in groups and introduced the problem or opportunity to focus. And for that, then after that, participants had like 60 minutes to work on the conceptual solutions with the KARAKURI cards. And they also had some extra time at the end to draw storyboards of the solutions. To finalize the workshop, then participants presented the results the different groups presenting the results to the other groups of participants. And on the left picture, you can see a picture of the pilot session where participants sat around the table to discuss potential solutions with different Internet of Things technologies. And on the right picture, you can see a later workshop where participants discuss a conceptual solution on the whiteboard. All the groups that took part in the workshop sessions were capable of understanding the problem they were faced with, were able to engage in discussing using the technological terminology of the different KARAKURI cards and Internet of Things technologies, and could present possible conceptual solutions that can be implemented with the modular hardware kit at a later stage. Our findings indicate that software personnel with the KARAKURI cards can ideate Internet of Things solutions at a conceptual level in order to solve real problems and take advantages of opportunities within industrial settings. To reach the final conceptual solution in the form of a diagram, participants drew factory locations and machinery schematically, arranging the cards and indicating the relationship among technologies, places, and people with lines and arrows. We see these conceptual solutions as a necessary step before the shop floor personnel engage in computational thinking and prototyping, which is considered the next stage in the KARAKURI methodology. Thank you for listening, and also we would like to thank our partners and participants.
Welcome to this pre-recorded presentation of the Design 2020 paper, A Formalization Approach for Collaborative User Experience Design. When we do user experience consulting, we observe the following challenges. Products become increasingly complex and must be designed and implemented in ever shorter time. Product owners have to deal with massive time pressure, and they have to efficiently manage cross-functional teams. So there is need for process models to deal with organizational knowledge. One central answer was the development of agile process models such as Scrum, but especially Scrum mostly refers to implementing the product and not to its conception. So we think a conceptual combination of a process model for UX design coupled with an approach rooted in engineering-related design theory and methodology could be a useful concept to tackle complex and open-ended problems, and a concept which is measurable, standardizable, and teachable. For this reason, our paper explains key features of the collaborative user experience design, first by discussing Cook's foundations, and then we outline the Cook's process, which divides product development process into 3 distinct phases, which are iteratively linked, each consisting of different workshops and methods. So the next question is how to conceptualize Cook's with more formalized approaches from design and engineering, with several models in design theory and methodology existing in parallel. An integrating framework is considered useful. Such is presented by the characteristics properties modeling, property-driven development CPM-PDD. The most significant feature of CPM-PDD is its differentiation between characteristics and properties of a product. The modeling of both the product and the process is a major advantage of the CPM-PDD compared to models mostly focusing on the process model, like Cook's alone, because it provides a clear framework for evaluation and process control due to its strong focus on analytical rigor. In order to combine Cook's with CPM-PDD, each phase of Cook's is considered separately and compared with the contents of the CPM product model and the process steps of PDD. We start with the understanding phase, where fundamental and necessary components of a product are created and defined. A result of this phase is a quantity of the product's required properties. These are determined in a human-centered manner to promise a good matching with stakeholders' requirements and external conditions. That means the framework conditions under which the later relations are valid. The following exploration phase is an iterative sequence of ideation, conceptualization, prototyping, and validation. Ideation is supposed to generate as many ideas as possible for the identified user requirements. The user requirements are mostly considered individually and translated into features. For CPM-PDD, this means that there is a multitude of different CPM product models based on individual required properties. In order to obtain results that completely fulfill the problem, conceptualization more strongly integrates the user requirements. For the considerations in CPM-PDD, this means that there are fewer different CPM product models, but these fulfill already several required properties. Prototyping produces the first tangible results. It focuses on one or very few variants that already integrate many of the user requirements. The range of these prototypes extends from low to high fidelity. For the CPM model, this implies that almost all properties required are considered in the analysis step. Finally, the validation workshop determines the fulfillment of the user requirements by the prototype. For CPM-PDD, the analysis of the submitted solution is in focus. The individual properties are evaluated with regard to their target fulfillment. In the realization phase, in the sense of the MVP and the lean approach, it is intended to implement a part of the most important requirements. This fact can be delineated very clearly in the CPM model, since it becomes visible with which characteristics are necessary for the implementation of the MVP. In sum, we identified relevant touch points for the two Cooks and CPM-PDD approaches. Future work needs to illustrate the value of this conceptual approach by using it as a framework in case studies from the engineering life cycle, and to further expand it in our academic engineering curricula and coursework.
I'm Alex Kimber, co-author of the proceedings paper, Making the Most of Makers, an exploration of the need for a prototyping tool for companies to engage with the maker movement. This paper was in fact one of two papers I wrote for my master thesis project. The overall thesis proposal was the design of a prototyping tool for engaging with the maker movement. A few key points were identified in the initial literature review. Prototyping is critical for innovation, despite the potential for early phase design fixation. Businesses are already turning to the maker movement for innovation, such as building in-house corporate makerspaces. Participatory design and open design paradigm shows us that there is a shift in the role of the designer to more of a facilitator. Makers can be seen as experts in low-fidelity prototyping by applying DIY principles such as repurposing functional components. And makers are motivated by joy and learning opportunities. There are a number of existing tools in this context, but there is no such tool that is specifically designed to help companies engage with the maker movement with the aim of improving prototyping activities. So, since prototyping is key for designers, makers are adept at prototyping, and no such innovation tool exists to help designers utilize makers to improve prototyping, this begs the following research questions. How beneficial would such a tool be? And what would be the design considerations for such a tool? Or in other words, what would be the design specification? This explorative study lended itself to qualitative data, which in this case was interviews. However, due to the breadth of companies and makers, survey data was also collected to support the qualitative insights. So this led to the research design being a fully mixed concurrent dominant status design, which means that the qualitative interview data was primary in the analysis, but supported by the quantitative survey data. The main conclusion was that some of the expected benefits of a tool designed to aid companies in engaging with the maker movement to improve prototyping activities would include a wider range of prototyping materials, more elegant solutions, and reduced development costs. The paper also proposed 12 design specifications to help guide the future development process of the tool. But one paper makes not a whole thesis, and I set out to propose a tool. So after reviewing the best practices of existing tools, such as the ID cards from Loughborough University and the team alignment map, I started work on developing my own framework and a prototyping tool. I started iterating a tool concept and prepared to stress test it in a workshop with makers and designers together. I continued iterating, collecting feedback from experts and makers along the way, until I finally developed the Prototyping with Makers canvas. It has a Creative Commons attribution, so please feel free to take it, remix it, and apply it commercially. Fundamentally, this tool helps designers and project managers make the right considerations and set healthy expectations when going into a collaboration with makers to improve prototyping. And the tool, along with supporting materials to help explain how to apply the tool, is publicly available at prototypingwithmakers.com. This work is academically relevant because there is a published paper and a publishable second paper contributing directly to the discourse. And according to Smythe and Helgeson, the development of tools relating to makers and designers contributes to an underexplored area of technology and design research. And the proposed tool can form part of a selection or system of prototyping tools or be used as a platform for future research. In industry, the use of this tool could improve design outcomes, lower development costs, and provide a low-risk approach to optimizing the design process. I believe an opportunity has been identified here in leveraging the maker movement to improve prototyping. A tool like the Prototyping with Makers canvas, like many existing tools within the widening open design paradigm, could help designers really make the most of makers. My solution is certainly a step in the right direction. It is available for companies to use and academics to investigate further. So thanks for listening, and please feel free to reach out if you're interested in developing or applying this tool.
Okay, so thank you for all the present speakers to have prepared this nice presentation. So I give the floor to the attendants if they have some questions, so they can signal they want to enter in the room. So Maria, can you explain them? Procedure. If you want to enter in the room, you can click on the blue button. Is it on the left, the right of your screen? That's the case. Okay.
Question, please click share audio and video button on the top right of the black part of the screen.
And you can also use the chat if you want. So we had 5 nice paper, 1 more theoretical, 3 for more experimental one, and 1 presenting a tool for maker. I guess we can discuss also the meaning of prototyping, which can be different in the different papers, because the purpose of prototyping for the makers is maybe delivering some solution, and prototyping in the design process is more elaborating. So, but of course, the elements are mixed in the process. So I have seen in the chat that the first question from Kristian Morfel. So if you want to share your question orally, Kristian, or Daniel, if you want to have
So as I see that Kristian has no audio connection, he asked how do we link essential aims of UX design, such as addressing hedonic qualities, with our approach? And that's a very important question from Kristian, because it points in some way to a overall trade-off problem. We, on the one side, if we can, so we can see that we have in the COOCS collaborative UX design process those 3 phases with several workshops, and in these several workshops we are able to address with different methods such qualities like hedonic aspects of a proposed product. But on the other side, with the CPM PDD approach, it's in some way more standardizable and teachable, or at least quantifiable. And that's in some way more or less always a problem, how to balance the more qualitative side of product design with a more quantitative approach, where you want to have want to rely on very basic measures or metrics like this. So that's just a very important point to think in further elaborations of this approach, to more actively stress such aspects like hedonic qualities.
Okay, I had something maybe linking this your paper and the paper 2, because you had said that the method you propose, how you enter with requirements, and in the presentation of Välk, we had a vision of framing the problem, which is also elaborating the problems and some of the solutions. So I was wondering how you can model these properties, so how you put characteristics. Are they characteristic on the problem or on the product side? And how you define properties and characteristics in the framing of the problem and the mediation of it.
So the framing happens in I guess in the overall phase of understanding the context, the problem, the context, the stakeholders involved. And as I wanted to stress in the COOCS CPM PDD synthesis, in the understanding phase, there's a lot of products required properties. So, and through the process, we have to in some way sort some out and to just point to the most important properties required in this way. I would say so. That's also pointing to this first question, that there is a in some way not always easy trade-off to work with.
Okay. I have a question from Eric to Sander. Eric, you can share it directly. Yes. Can we see you? Oh, I tried to. Ah, yes, Eric is coming.
Hi, can you hear me okay?
Yeah.
Okay, hi everyone. Thank you for your presentations. This question's for Sander. It sounds like you observed objects that transitioned in the way that they were being used. So for example, being used to explain and then to generate. Maybe I misunderstood you, but if there were transitions, could you explain a little bit more and maybe give an example of when that occurred, and comment on the conditions of the context when it occurred? Thank you very much.
Yeah, sure. Thank you, Eric, for the question. I think it's an interesting point that there's a sort of transitioning of different types of boundary objects. Based on my findings and insight, this wasn't exactly what was observed. So what I observed was that there were different categories of boundary objects. And now thinking back about it, it's indeed true that some of them evolved and took shape in all these different formats. So, for example, at first, there might be an explanatory boundary object. For example, let's say the designer and the scientists are having a discussion, and how this discussion oftentimes would go is that it's kind of oftentimes led by the designer posing questions, and be about very, very simple questions. Can this be done, or can this not be done? I think that's a problem in itself, but I'm going to go into details on that right now. But let's say they are having this discussion, and the scientist is explaining about a concept. Let's say it's a biosensor that has the capability to detect an antibody on a piece of paper. So this would be an explanatory boundary object. Then this could be recorded on a piece of paper and put on the wall, out of sight, out of mind, and the discussion would go into a wholly different direction. It would become a generative boundary object if it's actually acted upon or used somehow in coming up with a new idea. And the generative boundary objects were also the ones that that embodied some sort of a physical doing of something, and you can actually see both parties being engaged in the activity. So I'm not entirely sure if that answered your question, but do let me know if you would like to have that clarified.
That does. Thank you very much. That's very interesting.
Yes, but it means that you consider that the
Thanks.
properties are properties of the boundary object, because my perception is maybe that the boundary object cannot be analyzed outside of the activity. So it has no property in itself. It's just the activities that give the meaning and the sense of in which the boundary object is used. Because it's really a concept which comes from interactions. And if you suppress the interaction, you cannot completely define the category of boundary object, because the category is given in the action. No? It's not separable. You make the hypothesis that it's separable. I'm not sure I agree with that. That's the question.
I think that yes, I think it's a good point that this was the hypothesis, that you can make these classifications. But if you do look at the definition, then it suggests that boundary objects can have very different qualities and embody different interactions. And not all of these interactions are sort of actionable or something that incites co-doing. But they are still boundary objects, and they might still play a really important role in this process of evolving towards generative boundary objects. So what I'm trying to say is that it's quite easy to see that the generative boundary objects would lead to, say, framing or more creative ideas. But I think what's also important is to acknowledge that there is this journey, and you need to build up this sort of knowledge up to that point where you can create this boundary object that is a generative in its nature. But I think what's important and maybe a next step in the research is to understand this process of how these different categories of knowledge blocks will be formed into different novel ideas.
Yes, because some studies about sketches have shown that sketches can be generative.
Oops, sorry, I think we
lost our chair, yeah. Please refresh your page, Dr. Blanco, if you're still here. He entered the session again, so we're just gonna wait for a few seconds for him to return. Right.
Thank you.
Dr. Blanco?
I'm sorry.
Quite well. We just cannot see you. While Dr. Blanco tests his equipment, does anyone from the audience have a question for our speakers? Or perhaps speakers have a question for each other?
I don't have any specific question, but perhaps we could keep our captive audience by just broadening the conversation towards something that I'm interested in co-design is the cultural differences between designers and the design team and the co-design participants. So perhaps if anyone has any comments on how co-design methodology can alleviate this difference in work culture or creative culture, that might be interesting to me.
I'm sorry. Can you have any?
We can hear you again.
Yeah, maybe we can meanwhile carry on the discussion. And I think, Alex, that's an interesting point
Yeah,
about
sorry,
the sort of culture.
I'm sorry, I was completely disconnected. I have to renew the connection. Is it okay? You can hear me? I'm sorry. Don't know what happens. Is there any question?
Question which was really interesting. So
okay. Yes. Great.
Yeah. So I could quickly repeat the question so you can catch it. So it wasn't a specific question, but I wanted to open up and broaden the conversation towards cultural differences between the participants and the design team, and whether co-design methodology has anything to offer in alleviating the perhaps creative and productive cultural differences, like creativity and productivity differences between the participants and the design team. Thank you.
Yeah, yes, maybe I can start answering the question. In my context, the participants that I normally facilitate are from industrial contexts, and that means like normally they are operators that are normally doing routine work, and especially now in the literature of Industry 4.0 and before, they are described also as kind of like they perform routine work, and sometimes their work is a little bit boring because it's repetitive tasks. And when we are thinking about facilitating them, it's a little bit different because then they have to identify themselves with something more creative. And then when we're approaching the co-design sessions, then it's like we are also trying to engage people that are maybe not having like this computational knowledge. And support them with inbuilt technology and design support, so they can, for example, ideate and conceptualize solutions with Internet of Things technologies. And also we are now having other projects with other technologies too. So I think it's an interesting question. And in my experience from the projects that I had in the past, something that it helps is like, is the activities in the co-design sessions, and how do you prepare for them, and actually how do you plan and study the participants before, even though sometimes it's actually quite difficult to understand their context before you are with them. And I don't know if I'm answering, but
yeah, that's really insightful. Perhaps I could just jump on that final point that you make about preparation, even though you might not understand their context so well. If I take your meaning, learning about the participants themselves personally and trying to integrate that into the planning. Is that okay? Cool. Thank you.
Other question from the audience, or I had one for Álvaro, because maybe relative to the presentation of Sander, is how do you when you present your cards, it's more a combination of solution, and the principle of the use of the cards, that you can combine the different solutions using the different cards, if I understood. But did you identify some emergence of solutions which are out of the cards possibilities? And did you find also some different type of boundary object that can be played by this card at different moments of the activities? If we go back to the typology of Sander, proposed by Sander, can you?
For the first question about emerging properties with the cards, one of the things is, like, especially in future workshops, I mean, not entirely for this paper, and also in this paper, when they were in this stage, when they were using the cards, something that we noticed is, like, they were not only using the cards for coming up with a solution and documenting it in the form of diagrams, but also they were pointing at them and they were taking them and they were actually using them as props to role play. So, for example, if a sensor was triggered, then they would shake the card as to indicate that the sensor was triggered, and then with the other card would say, like, and then these people would notice that something is happening. So in that sense, there were some emerging properties that were happening when we were testing the cards in the design sessions, and we are planning to rethink a little bit the cards maybe into something different. So it's easier to role play with the cards, different scenarios with Internet of Things. And regarding boundary objects, on the one hand, is like participants, even though they have this industrial background and they are from the shop floor, they have totally different backgrounds. Some people are working with logistics, some people are working with maintenance, and so there are many different roles. And in this sense, it's like the cards can provide like a common language so they can discuss. But also, I see in a more generic view that also the cards could act not only as boundary objects between them, but also once they have come up with a solution as a team in the co-design process, like maybe if they are not able to fully develop the prototype by themselves later, on a later stage, they can use the diagram, the resulting diagram with the cards as a boundary object also to communicate with people that are more have a background in information and technology, so they can communicate what is their need, and then IT people can take it over and prototype it. So I see these use cases with the boundary objects in the project that I'm doing now. And it's a very interesting question.
Thanks, Álvaro. Maybe I can just ask a quick follow-up from a very selfish perspective. How did you define the contents for the cards, or what was your process for defining what sort of information and how this information should be presented on the card?
Actually, in the beginning, it was more that we had like a pilot session, and from the pilot session to the kind of like the final prototype of the cards, there was a lot of small changes. But in the beginning, it was more about exploring what Internet of Things technologies are out there in the market. And then we are in our interdisciplinary teams, so we have experts in Internet of Things, and we have also experts in production in industrial settings. So then we were looking at the different sensors that are in the market and also thinking about which ones could be applied in industrial contexts. So from those, we had a selection of I don't know if I remember correctly, but I think it was like 40 or 50 cards. And then from that, we ran a pilot session. And from the observations of the pilot session, then we discovered like, okay, for example, if you give a card of accelerometer to an operator, maybe that person doesn't understand very well how to use an accelerometer or what does an accelerometer mean. So we saw like there was a need to also explain further a little bit some sensors, and also like there were some possibilities, for example, to include some color coding to define, for example, like there are sensor cards, but there are also like ways to notify people about the sensors. There are also ways to visualize. So then we started to see like these categories and other ways of providing better ways to support participants. So as a quick answer, I can say like it would be more like it has been an iterative process. So we started from like what is already in the market in terms of technology, and then we were trying to, based on the observations from the first workshop, I think that was a pilot, then iterate, and we're still, based on these workshops, also iterating the kit.
All right, thank you very much.
You wanted to ask a question to Alex? Take the... Or maybe Alex, you can see the question in the chat, so you can elaborate on it.
I can see the question, and just to quickly summarize, it's the use of anonymity within the team, because the hierarchy between participants can sometimes affect the dynamics of the group. And I think that's a really interesting point. In terms of how it relates to my work, I did not work with anonymity, and that's not been factored into the tool that I've developed, but it's something I'm really interested in. I was in the talk about status anonymity on Tuesday, and I'm really interested in trying to apply this concept in the collaborating with makers context. There is one point, however, which I can think of which might contradict this, which is something that needs to be experimented with and kind of worked on, and it's to do with maker motivation. There's some literature on what motivates makers in the maker movement to make, and one of the intrinsic values among joy and learning is reputation. More experienced makers can be motivated by their reputation in how well they produce and how many kind of novel things they make and share in the community. So this idea of maker reputation motivating the participants could be in contradiction to anonymity, despite the fact that the idea is also really interesting in trying to flatten hierarchies within group dynamics. So it's something I'm really interested in. It's not currently incorporated in the tool, but it's something that's definitely worth looking into. Thank you.
Okay, we are still 5 minutes for question in the audience or from the speaker themselves to another one. So maybe Alex, if I can come back to this question of mediation finally that we put on the we have on this discussion about the different point of view of mediation from Maud to Sander, and also you propose tools to help the collaboration. Maybe we have also a question today, as we can see in this conference, that we go online for most of our life. And all this approach of prototyping and tooling are facing today to this difficulty of online collaboration, and we see we are hand attached on on our back for working on the design activity. So how maybe you have some elements from some of you about this challenge of getting online or going online for this elements?
I think it's a really real and current challenge. I mean, unfortunately, my paper was written BC before Corona. So it's a little bit outdated in that sense. And with the type of field that I'm working in, it's very much physical prototyping. So trying to get makers in a room, in a workshop ideally, physically producing low fidelity mock-ups and principle proving prototypes with the designers is, in terms of Corona and social distancing, a monstrous challenge. And something that my tool hasn't taken into account for. So it's definitely
yes. But if we consider, sorry, I interrupt. But if we consider the community of makers by constitution, they are distributed all over the world. So it's not maybe a local collaboration. It can be something completely online by construction.
That's very true. And one of the challenges to that, which I identified, was a logistical challenge. The makers are out there and they work very efficiently within their communities, but the type of communication channels that companies work with are very different to the channels that makers work with. Local maker organizations are often Facebook pages, WhatsApp chats, local communication channels, which companies, particularly larger corporations, don't have that kind of culture and don't align with those communication channels. So my tool helps companies to just consider this fact that, you know, if you want to reach out to your local maker space, their email might not be available. There might not be a number on there. That you might just have to know the person and get access to their WhatsApp group. So there's a very real logistical challenge to accessing this distributed network.
Yeah. And also other reaction on it, on the post-corona era? No reaction from the other speakers.
Well, my initial reaction would be that prototyping is becoming even more important than it's ever been, because the prototype is a sort of a form that embodies the functions so well that, you know, that can't be done via a description or a sketch or maybe a 3D drawing. So I guess we kind of need to develop new means and technologies to maybe share these prototypes. I'm just thinking about even student teams working together on projects, and the team members have been scattered around the world. They're kind of shipping prototypes from one home to another to test them out, or because they don't have 3D printers at home, so that they could all print the same prototype, for example. So I think there is definitely some room for improvement, or how technology and design can make an intervention to sort of facilitate this gap that is currently there due to the crisis that we're going through.
So I think it's almost time to close the session. So thank you for all the presenters for having doing good presentation, recorded presentation, that we are very clear of the most important elements of the paper. And thank you for this discussion. I can't say, unfortunately, see you at the coffee time. That's a pity. So thank you very much for your time, and I hope the discussion can continue in between you also speakers, but maybe there is some attach you can go and discussion the different type of tools and type of elements you put on the table there. So
Thank you very much.
Thank you.
Thank you very much.
Thank you.
Thank you.
Bye.